Hello everyone. Today we're going to take a look at temperature and heat and what the difference between the two is. So hey, grab your notebook. We're going to go ahead and write these notes down, and then we're going to move to the lab to do a little mini lab with water and food coloring. So here's our essential question. What is the difference between heat and temperature? By the time we're done with these notes, you will be able to answer that question. Some people think that sometimes the heat and temperature are the same thing. Well, they are related, but there is a major difference between the two. So let's investigate this, shall we? All right, temperature. Temperature, we know, is something that we can measure with a thermometer, like this one over here. This is a Celsius thermometer. And temperature, because it can be measured, is a measure of the average value of the kinetic energy of the molecules in random motion for an object. In the SI system, the one that we use for the sciences, the temperature scale that we use is the Kelvin scale. This is also known as the absolute temperature scale, where we get that absolute zero from. So temperature, it's a measure of the kinetic energy of the molecules. Next, we move on to thermal expansion. Thermal expansion is a property that almost all substances have. There's only a few that don't. Almost all substances expand when they are heated, and they contract when they're cold, except for water when it freezes. Water has a tendency to expand when it freezes. It's just kind of strange that way. So we see here in this picture here, this is an expansion joint for a bridge on a road. The reason why they started putting those on bridges and stuff is because of the freezing and thawing of the winter, and then also the big expansions that would occur in the summers. These joints would help the roads from buckling and causing all kinds of damage and things like that. So thermal expansion, that happens. Sometimes even different designs are made to account for thermal expansion. A lot of engineers put things together to make sure that they understand thermal expansion. Okay, thermal energy is our next key term here. Thermal energy is the sum or the total of the kinetic and the potential energy of all of the particles in an object. As the thermal energy of a substance increases, it also increases with the temperature. Okay, moving on. Next, we have these different temperature equations to convert from Fahrenheit to Celsius, from Celsius to Fahrenheit, from Celsius to Kelvin, and then Kelvin to Celsius. All right, so if we wanted in the Fahrenheit temperature scale, this is what we use in the United States. Like if we say it's like 75 outside, or if we say it's 105 outside, we're talking about the Fahrenheit temperature right there. Okay? Now to convert this to the Celsius scale, well, in your mind you may be like, why would we want to do that? Well, we do that mainly because almost everybody in the world uses the Celsius scale. We don't. So it's always good for us to be able to communicate globally. So to convert Fahrenheit to Celsius, we use this equation right here, this formula. I'm sure this is something that everybody's used before. We take 5/9 times the difference between the Fahrenheit temperature minus 32. Make sure we always do what is in parentheses first. Then to go the other direction, to go from Celsius to Fahrenheit, say you are in Mexico or Canada, or even you go on an overseas trip to Russia, and their temperatures on the news and stuff like that, they're saying them in Celsius, and you're like, oh, I don't know what that is. So we're going to go ahead and use this formula so that we can understand what they mean by that temperature. Yeah, there's online converters too, but it's always good for us to be able to do this as well. So here is the equation that we would use to go from Celsius to Fahrenheit. We take our Celsius temperature, we multiply it by 9/5, and then we add 32 to the end. Okay, down here, we're going from Celsius to Kelvin and Kelvin to Celsius. And this one's a little easier. We don't have that little fraction in there to multiply by. But what we've got is to go from Celsius to Kelvin, we take our Celsius temperature and we add 273. And then to go from Kelvin to Celsius, this is if we're given the Kelvin temperature and we wanted Celsius, we would subtract 273. Now, if we wanted to go from the Kelvin scale right here to the Fahrenheit scale, what we would want to do first is to convert Kelvin to Celsius using this scale. Then we would convert Celsius to Fahrenheit using this equation right here. Okay? That's how we would go about doing that. It would be a two-step process. Also, it would be two steps if we wanted to go from Fahrenheit to Kelvin. We would first go from Fahrenheit to Celsius and then Celsius to Kelvin. Okay, next we have the definition for heat. Okay, heat is thermal energy. Energy, it's a form of energy. It's not a measure of kinetic energy like temperature is. Okay, so thermal energy that flows from something at a higher temperature to something at a lower temperature. And there's a whole lot more to it than that, but we're going to stick with this. So heat is thermal energy that goes from something that's hot to something that's cold. It never goes the other way. Okay? Specific heat, this is a specific amount of heat needed to raise the temperature of 1 kilogram of some material by 1 degree Celsius. That is specific heat. And next we're going to take a look at some different substances and their specific heats. Okay, here are some common materials that we use on a regular basis. We've got water, wood, carbon, glass, and iron, and their specific heats. Okay, we see here that the specific heat is measured in joules per kilogram degrees Celsius because it's the amount of heat in joules, because heat is energy, that causes 1 kilogram of a substance to increase by 1 degree Celsius. Okay, so the specific heat of water is a very, very large amount. It's 4,184. Wood has a relatively large specific heat as well. It's 1,760. Carbon, this is the stuff that you're writing on your notebook with if you're using pencil. Carbon has a specific heat of 710. Glass has a specific heat of 664 joules per kilogram degrees Celsius. And iron, being a metal, has the lowest specific heat of 450, which makes sense because iron is a metal. It's a really good conductor. It's not going to hold on to that heat. So these are just some common specific heats that to kind of get your mind wrapped around this idea. Okay, our next thing we're going to do is we're going to take a look at the thermal energy equation. Now, unfortunately, we're not going to have time to use this a whole lot, but I wanted you to see it. I want you to be aware of this equation. This is how we are to calculate the change in thermal energy, or the amount of heat in a substance, if there is a temperature increase. Okay? So what we're going to do is the amount of heat, or the change in thermal energy right here, that would be in joules, that is equal to the mass in kilograms, see, mass in kilograms, times the specific heat, which we just talked about, in joules per kilogram degrees Celsius. That's where this little c is right here. That's the specific heat. Times the change in temperature. That's where this delta, Greek letter delta T, comes from. And this would be in degrees Celsius. So this is our thermal energy equation. And like I said, we are not going to have a lot of time to work with this, but I wanted to throw that out there so you could see it. Okay, so finish up these notes and let's get ready to do this little lab, okay? Have a great day.